This is Bob Capetta from the College of the Florida Keys, and this lesson is an introduction to polynomials. So the following function, f of x is 3x squared minus 5x plus 7, is a polynomial function. X with various integer powers, summing up the various terms is what we're looking for. So a polynomial doesn't have a square root of x, a polynomial doesn't divide by x. Polynomials have x's with integer powers, positive integer powers, and coefficients. So in this situation, we want to find f of 4. When you want to evaluate any function, plug in the value in parentheses. So what we've done here is we've taken 3x squared minus 5x plus 7, plug 4 in 4x in parentheses. The order of operations tells us to do the exponent first. 4 squared is done before the 3 times 4. Exponents come before multiplication in the order of operations. So 4 squared is 16, 3 times 16 is this piece. Multiplication comes before subtraction, so 5 times 4 is 20 plus 7. Multiplication here, 3 times 16 is 48, minus 20 plus 7 gives us a total of 35. Now here's another example with that same polynomial function. We want f of negative 2. So plug negative 2 in parentheses for x. So 3 times negative 2 squared minus 5 times negative 2 plus 7. Again, the order of operations tells us we do this exponent first. Negative 2 to the second power means negative 2 times negative 2, which is positive 4. So we have 3 times 4, and then this is negative 5 times negative 2, which is positive 10, plus 7. 3 times 4 is 12, plus 10, plus 7, and we get f of negative 2 is 29. Now we're going to talk about adding like terms here. So 2x plus 3x, how to think of that? Well, if I said 2 million plus 3 million, you would say 5 million. We just kind of extend that idea. So 2x plus 3x has to be 5x. Now how can I convince you of that? I want to think about this in terms of the distributive property. Notice, if I write it this way, distributing 2 times x is 2x, 3 times x is 3x. So indeed, 2 plus 3 times x is equivalent to 2x plus 3x. And of course, quantity 2 plus 3 times x has to be 5x. So similarly, if I have 7x squared plus 3x squared, same kind of argument. That would be 7 plus 3 quantity times x squared. Distributing 7x squared plus 3x squared is what that has to be. But 7 plus 3 is 10, so the result must be 10x squared. Now how do I handle 8y plus y? Well, when you have a variable by itself, it's helpful to put a coefficient of 1 in front of it. So now I have 8y plus 1y, and it's much simpler to do. In that case, again, factor out the y, parentheses 8 plus 1 times y. 8y plus 1y will give me a total of 9y. So indeed, 8y plus y is 9y. Next up, I have 4x plus 5x squared plus 3x plus x squared. Now notice the y over here did not have a coefficient, so I put a coefficient of 1. The x squared doesn't have a coefficient, so I can put a coefficient of 1 as well. So we have 4x, 5x squared, 3x, and 1x squared. But let's rewrite them so that the like terms are together. 5x squared plus 1x squared first, 4x plus 3x second. So I can rewrite 5x squared plus 1x squared as 5 plus 1 times x squared. And I can rewrite 4x plus 3x as 4 plus 3 times x. So what does this have to be? 5 plus 1, 6x squared, plus 4 plus 3, 7x. So things are like terms. You can add them together if the variables are the same with the same powers. But you can see that in terms of how our factoring distribution process works. So here's a more complicated one. I am adding 3 polynomials together. It's addition. So I don't really need these brackets, these parentheses. I can write it straightforward. Now if there's a minus sign in front of parentheses, then you better distribute that, but that's not the case here. So I have 3x squared minus 5x plus 4 plus 2x squared plus 7x minus 9 plus 1x squared, again no coefficient here, minus 6x plus 3. So I wrote all of the x squareds together, 3x squared plus 2x squared plus 1x squared here. All of the x's together, negative 5x plus 7x plus negative 6x. and then the numbers 4 plus negative 9 plus 3. So you can see if we factored out the x squared, you'd get 3 plus 2 plus 1, or 6x squared for that first piece. Similarly, negative 5x plus 7x plus negative 6x will give me negative 4x. 4 plus negative 9 plus 3 is negative 2. So 6x squared plus negative 4x plus negative 2, which of course is equivalent to 6x squared minus 4x minus 2. So here's another one where the coefficients are a little bit more complicated. I have some x's, some y's, squares. Terms are like terms if the variables are exactly the same and the powers are exactly the same. Again, addition, addition, so I don't really need the parentheses. But I've rewritten this minus 4xy squared as plus negative 4xy squared. I've rewritten the minus 5x squared y as plus negative 5x squared y. And I've rewritten 1x squared y for x squared y. So now everything has a coefficient and everything is addition. So where are my like terms? What am I going to combine together? First off, the x squared y's. So I have 2x squared y here, negative 5x squared y here, 1x squared y here. So those are all the x squared y's. Next I went to the xy squareds. Here's an xy squared. Here's an xy squared, only two xy squareds. Then we look for y cubed, 8y cubed here, 2y cubed there. And then the numbers 6 plus 9 here. So adding our like terms, 2x squared y minus 5x squared y would be negative 3, plus 1, negative 2x squared y is my first piece, and you can see that. How about the xy squareds? 7xy squared, negative 4xy squared gives me 3xy squared. The y cubes, 8y cubed plus 2y cubed is 10y cubed. And finally, 6 plus 9 is 15. So that's that situation. Our next example is a subtraction. So this is going to require some sort of a distributive property. So we're going to rewrite this as 3x squared minus 5x plus 2 plus negative 1. So plus a negative, and I'm going to just throw a negative 1 in there, and I'm going to distribute that. So this negative 1 will be distributed into all of these. Or think of it as a negative sign. The negative sign is distributed into all of the terms in the following trinomial. So negative 1 times x squared is negative 8x squared, Negative 1 times negative 6x, positive 6x. Negative 1 times 5, negative 5. Now that there's addition between these two, I don't really need the parentheses. So I'll just write it as 3x squared plus negative 5x plus negative 2 plus negative 8x squared plus 6x and minus 5 becomes plus negative 5. Like terms, 3x squared plus negative 8x squared would be negative 5x squared. Negative 5x plus 6x is 1x. Negative 2 plus negative 5 is negative 7. And we will probably write that in a cleaner way. 1x, of course, is the same as x, plus negative 7 is, of course, the same as minus 7. So a cleaner solution is negative 5x squared plus x minus 7. All right, next we're going to multiply 7x to the 4th times 3x to the 5th. Both of those are monomials, one-term polynomials. We're going to multiply them together. So no need to distribute. We don't have multiplication and addition in the same problem. So let's ask ourselves what this means. 7x to the 4th means 7 times x times x times x times x. 3x to the 5th means 3 times x times x times x times x times x. Well, we have the associative property, which allows us to reorder these. So let's multiply the 7 times the 3 together first, then multiply all the x's together. So thinking of it that way, 7 times 3, of course, is 21. And all of these x's, how many x's do I have? A total of 9. So we'll have 21x to the 9th will be our answer for that one. So that's our strategy for multiplying monomials. Multiplying binomials, we want to use a slightly different strategy. So I have 3x minus 5 times 2x plus 7. Many students learn the FOIL method, first, outer, inner, last. That is not my preferred strategy because it doesn't generalize beyond binomial times binomial. What I do instead is I draw a box, 2 by 2 box, because there's two terms here, 2x plus 7, 3x minus 5. And then in each of these cells, I take the product of the horizontal piece and the vertical piece. So for example, 2x times 3x is 6x squared. I put that in that spot. You think of it sort of like length times width is area. In this slot, I have 7 times 3x, which would be 21x, and I put a plus sign there just for emphasis. Here we have 2x times negative 5. 2x times negative 5 is negative 10x. And finally, 7 times negative 5 is negative 35. Now I can add the like terms. You'll notice the only x squared term I have is 6x squared. But on the x's, we have 21x, and we have negative 10x. 21x plus negative 10x would give me 11x plus negative 35. So putting all those together, our answer is 6x squared plus 11x minus 35. So notice I'm able to do that without using FOIL, just doing term-to-term multiplication using the standard distributive property. All right, next I want to look at 2x squared minus 3x plus 1, a trinomial, times 5x minus 4, a binomial. So we have something with 3 terms times something with 2 terms, which means that the result is going to start with 6 terms. I need 6 products to do that. So my 2 by 2 box is not going to work. I need a 3 by 2 box this time. And we're going to write 2x squared minus 3x plus 1 down here in each piece for each term. 2x squared minus 3x plus 1, and the other terms are 5x plus negative 4 or 5x minus 4 for each term up here. But the process is the same. In each cell, I need to put the product. So this first product here, 2x squared times 5x, 2 times 5 is 10, x squared times x is x cubed. That first piece will be 10x cubed. Next up we have negative 3x times 5x, negative 3 times 5, negative 15, x times x is x squared. Negative 15x squared. Now 1 times 5x is, of course, 5x. Next up, I get 2x squared times negative 4. 2x squared times negative 4, 2 times negative 4, negative 8x squared. Next up, negative 3x times negative 4, which would be 12x here. And finally, 1 times negative 4 is negative 4. Now, where are the like terms? We have 10x cubed here. No other x cubes. The negative 8x squared and negative 15x squared, which will give me negative 23x squared. Then we have 12x plus 5x, which is 17x plus negative 4. So putting all those together, 10x cubed minus 23x squared plus 17x minus 4. And that will conclude this lesson.